Okay, the other day we talked a little bit about exponential functions. We're going to do a little bit more with exponential functions here today. But before we talk about exponential functions, I want to go back and talk about linear functions a little bit. Let's say I gave you that function, y equals 3x minus 2. You should immediately tell me that's a linear function. Why is that a linear function? There's no squared, there's no cube, there's no square roots, there's none of those things. Everything has power 1. If I build a table, let's say I plug in -2, -1, 0, 1, and 2. You should recognize a definite pattern. Let's see, if I plug in -2, I get -6 minus 2, that's -8. If I plug in -1, I get -5. Plug in 0, I get -2. Plug in 1, I get 1. And plug in 2, I get 4. What's the definite pattern? It goes up 3 each time. Each time when I go from -2 to -1 to 0 to 1 to 2, my y values go up by exactly 3 each time. Why do my y values go up by exactly 3 each time? Because the slope is 3, and that's what the slope says. The slope says if the slope is 3, if your x values change by 1, your y values will change by 3. All right, now, what about an exponential function? Y equals 3 times 2 to the x. Why is that an exponential function? Because the exponent's up in the variable. What if I make a table on this one? -2, -1, 0, 1, and 2. I'm going to start with the positive numbers at this time because they're easier. I plug 2 in. 2 squared is 4. 4 times 3 is 12. I plug 1 in. 2 to the 1 is 2. 2 times 3 is 6. I plug 0 in. 2 to the 0 is 1. 1 times 3 is 3. And then I plug -1 in. What's 2 to the -1? What's a -1 exponent going to do? It's going to make a fraction. So it's going to take that 2 and put it on bottom. So I'm going to have this 3, and then I'm going to have a 2 on bottom. That's 3/2. And then how about when I plug -2 in? -2, the negative is going to put it on bottom, and then it would be 2 squared down on bottom, so it would be 4 on bottom, 3 to the 4th. What's the pattern with exponential functions? What's that? They have. Okay, if you're going backward, they have. If you're going forward, they double. It's easy to see with the integers. If I go from 3 to 6, I double. If I go from 6 to 12, I doubled again. So, for linear functions, we add a number each time. For linear functions, we added 3 to each of the y values. What's happening with exponential functions? You're not adding by something, you're multiplying. And what are you multiplying by? 2. And 2 is the number that was right there in the base. This 3 turns out to be something important. What's the 3? That number 3 showed up right here in the table. What's that point called?
Y.
That's my y-intercept. So in this equation, y equals 3 times 2 to the x, the 3 gives the y-intercept, and the 2 gives the ratio. Similar to here, in this one, this -2 gave the y-intercept, and the 3 gave the slope. The numbers in the equation are something very, very important. Now, you might remember the very, very first day of class. Here's what we did. I might have given you 2 points. I might have given you the point 2, -4, and 0, 6, and said, find the equation of the line through those points. That was what we covered the very first day of class. Long time ago, seems like now. What did we do? If I give you 2 points, how do you find the equation of a line? First thing you need to do is find the slope. The most important thing about any line is the slope. So we find the slope. M is y2 minus y1 over x2 minus x1. That's going to be 6 minus negative 4 over 2 minus 0. That's 10 over 2, that's 5. And then what did we do once we knew the slope? Go ahead. Ah, very good. Everybody screws up, don't they? If I went 6 minus negative 4, you're absolutely right. I better go 0 minus 2. So I'll just change my sign. So you're right. Negative 5. See, everybody screws up. Easy to do. All right, so that's not arguing with me. That's correcting me. Slope is negative 5. That's better. Once we know the slope, what do? I can use y equals mx plus b. So y equals, what's my slope? Negative 5x. Do I happen to know the b number? Yes, I do happen to know the b number. Because I have 0, comma 6, my b number happens to be 6. I happen to know it. If I didn't know it, then you're right. I would use y equals mx plus b. I would pick one of the points, and I would plug in x, plug in y, and I could solve, and I could find b. All right, so that's what we did the very first day of class. I would give you 2 points. We would find the equation of a line. Later on in this course, we found equations of parabolas. We had a couple different ways to do that. How did we find equations of parabolas? What did you need to know? What's the most important thing about a parabola? The vertex. So if you knew the vertex, finding the equation wasn't too bad. If you knew the vertex, I'm not going to work these out because these tend to be a little bit harder. If you knew the vertex, you could use that equation. And you would plug in your vertex. Your vertex was hk. And then how did you find the a number? Oh, you needed another point, any other point, and you would plug it in, and you would solve and find the a number. So if you knew the vertex, finding the equation of a parabola wasn't very hard, not too bad. You still needed 2 points. What if you didn't know the vertex, however? Use what? You used a standard form. So you used y equals ax squared plus bx plus c. And how many points did you need to know? 3, because there's 3 letters you need to find, A, B, and C. You needed to know 3 points. So you plugged in 3 points, and you got systems of equations. You got 3 equations with 3 variables, and then you solved. That's problem number 2 on your test, by the way. I'm going to give you 3 points, and you have to set up the system of equations and then solve. All right, well, what we're going to do today is deal with exponential functions. Okay, so we have a big table here, and we have some functions. And it says some values of functions f, g, h, and k are provided in the table below. Find a possible function for each, either linear or exponential. Verify your results with a graphing calculator. Okay, so our x numbers are 0, 1, 2, 3, 4 for all the functions. And then we have this function, 2, 12, 48, 192, 768. We're supposed to decide if that's a linear function or an exponential function. Well, you got a 50-50 chance of being right. Linear or exponential? Exponential. Excellent. Why do you think it's exponential? I don't think it's cubed. Times by 4? Something's not quite right, is it? I think the teacher made a mistake on this one too. Let's make this first one be the number 3. Then, how do I go from a 3 to a 12? I multiply by 4. How do I go from a 12 to a 48? Multiply by 4. 48 times 4, I hope is 192. And 192 times 4 is 768. So this one is exponential. So what's its equation? Well, what's the y-intercept? 3. So it's 3 times, what's the ratio? 4. So it would be 3 times 4 to the x. That would be an exponential function. You can tell it's exponential because you're multiplying by 4 each time. G. Exponential or linear? Linear. Why linear? How about adding -6 each time? It goes from 19 to 13, it dropped by 6. 13 to 7, dropped by 6. Dropped by 6, dropped by 6. So G is linear. What's the equation for G? Close. What's the slope? The slope is -6 because it's going down by 6 each time. And the y-intercept is 19. So it should be -6x plus 19. You had your numbers backward. The y-intercept is 19. The slope is -6. All right, how about H? Linear or exponential? It's exponential. Okay. If it's exponential, what's the ratio? How much? -4, not -4. 1/4. Because to go from 32 to 8, I divide by 4. To go from 8 to 2, I divide by 4, and you can check the other ones. So I think h of x should be the y-intercept is 512, and then we have 1/4 to the x, which could be written using a negative. It could be written as 512 times 4 to the -x. But typically we would write it as 1/4 raised to the x. But it could be written using a negative power. And finally k. Linear or exponential? Linear. Why linear? Goes up 7 each time. So k of x is, what's the slope? 7x plus the y-intercept? 2. All right, so 2 of those were linear, 2 of them were exponential. All right, part 2. Solve each of the following equations. How do you solve b cubed equals 64? Take the cube root of both sides. To get rid of the cube, you do a cube root. So b is the cube root of 64, which I think is a nice number. Cube root of 64 is 4. Okay. How about part b? How do I solve 3b squared equals 12? Divide by 3, get the square thing all by itself first. B squared is 4. So b is 2. You're half right. Plus or minus 2. Okay, so how come on the square root I did a plus or minus, but I did not on the cube root? What's that? Well, look at my calculator here. Where did I put it? On the cube root one, would -4 be a correct answer? What's -4 times -4 times -4? -64. So when you do cube roots, you only get one answer. When you do square roots, you get two answers. All right. How about this one? 1.7b to the fourth equals 86.4. What would you do on that one? Divide first. Get the power all by itself. I get b to the fourth. It doesn't come out to be a nice number. B to the fourth is 864 over 17. And then how do I get the b all by itself? Take the fourth root. When I do fourth root, how many answers do I get? One or two? Two. Why two when I do a fourth root? There's an even amount of exponents. Correct. If I multiply something by itself 4 times, 4 negatives give a positive. So if you have a positive power, when you do roots, you're going to get 2 answers. When you have an odd power, you're only going to get 1. So this is plus or minus the fourth root of 864 over 17. All right, finally, part D. How would you solve that equation for b? b to the 8th over b cubed equals 79 over 5. Absolutely. We start by simplifying. On the left-hand side, we subtract those exponents. That's the same as b to the 5th is 79 over 5. Subtract the exponents. And then how do you get the b all by itself? Fifth root. How many fifth roots are there? Just one. B is the fifth root of 79 over 5. All right, well, being able to solve those little types of equations like that is exactly the skill we need in order to find equations of exponential functions. So, problem 3 says, find an approximate equation y equals ab to the x of the exponential curve that contains the given pair of points. Round the value of b to 2 decimal places. Okay. Y equals a times b to the x. Without doing any work at all, we should know the b number. Not the b number, I'm sorry. Without doing any work at all, we should know the a number. What's the a number? 3. Why is the a number 3? Because it's the y-intercept, and the y-intercept is given right there, 0, 3. So I know I'm going to have y equals 3 times b to the x. How am I going to find the b number? Plug in the other point. Very similar to what we did with linear equations. We're going to plug in the other point. We're going to have 100 equals 3 times b to the 5th. And then you need to solve that equation. How would you solve that equation? Divide by 3. So 100 over 3 equals b to the 5th. So b is the 5th root of 100 over 3. And it says in here to round b to 2 decimal places. So I'm going to take my calculator. I'm going to go 100 over 3 raised to the 1/5. Instead of using 5th root, I'm going to remember my properties of exponents. A power of 1/5 is the same as a 5th root. 2.02. So our equation would be y equals 3 times 2.02 to the x. right, problem B is very, very similar. Y equals a times b to the x. Do we know the a number? Yeah, the a number is 256, because it's the y-intercept given right there. Y equals 256 times b to the x. Plug in the other point. We have 23 equals 256 times b to the 7th. That's the same as b to the 7th is 23 over 256. So b is the 7th root of that. That's going to be 23 over 256 raised to the 1/7. And that we will call 0.71. So we would have y equals 256 times 0.71 to the x. Questions on either of those? All right, I'm going to skip part C. Really not much difference. The only thing with part C is we got some decimals. But decimals really shouldn't bother us because we have a calculator. Really not a big deal. D is different, however. We'll do D and E. What's different about D? I don't know the y-intercept. It doesn't give it to me. So what do I do? That's slope. y2 minus y1 over x2 minus x1, that's slope. And what's that used for? Linear functions. Is this a linear function? No, it's exponential. So we're never going to use that y2 minus y1 over x2 minus x1 in this section. Other ideas? Well, I'm just going to go ahead. I'm going to plug in both the points, I guess. I'll see what happens. So if I plug in the first point, I get 4 equals a times b cubed. And if I plug in the second one, I get 9 equals 4, not 4, a times b to the 9th. To the 5th. I already used the number 9, b to the 5th. Thank you. All right, hopefully I got the right numbers now. Now what? Well, we have kind of a weird thing. We have a system of equations. It's kind of a weird system. We have one equation with two variables, and then we have a second equation with two variables. We need to solve. How can we solve that system that has two equations with two variables? Now I'm going to take this first equation and I'm going to write it as a equals 4 over b cubed. So what did I do there? I divided by b cubed. And then I'm going to take that and I'm going to plug it into the other equation. So I have 9 equals 4 over b cubed times b to the 5th. I'm going to rewrite that. 9 equals 4b squared. How did I get 9 equals 4b? Or not? Yeah, 9 equals 4b squared. That's correct. How did I get that? I subtracted my exponents. How do I get the b all by itself now? Divide by 4. So 9/4 is b squared. So b is 3/2. Technically, I really should write plus or minus 3/2, but I'm not. I'm only going to write b equals 3/2. When we're dealing with exponential functions, this b number always has to be a positive number. We never use negative numbers here. All right, well, we have so far y equals a times 3/2 to the x. We're almost done. Now we're going to find the a number. What would you do to find the a number? Bless you. What's that? I did plug b in. I plugged b in as 3/2. How can I find a? Plug in one of the points. Plug in one of the points and work it out. Which one do you want to plug in?
3, 4.
3, 4. So 4 equals a times 3/2 to the 4th. Which means, it takes a lot of space, a is 4 over 3/2 to the 4th. And I guess I'll use my calculator to get an answer for that. 4 divided by 3/2 raised to the 4th. Calculator gives me an ugly decimal. That is 64 over 81. So I guess my final answer would be y equals 64 over 81 times 3/2 to the x. Yes?
Should we do this
Yeah, boy, I'm full of mistakes today, aren't I? You're absolutely right. I plugged in 4 for both x and y. That should have only been a cube there. Rats. Let's try it again. 4 divided by 3/2 cubed is 32 over 27. A is 32 over 27. So, final answer. After I butchered this one 3 times. Y equals 32 over 27 times 3/2 to the x. Questions on that one? All right, I think we better do E also. E is pretty much the same thing. The numbers are a little bit uglier. We're going to have y equals a times b to the x. Once again, we notice, unfortunately, that we were not given the y-intercept. If you're not given the y-intercept, you're just going to plug in both numbers. So you're going to have, or both pairs, 73.8 equals a times b squared. And then you plug in the other pair, you have 13.2 equals a times b to the 7th. Now, notice what happened back here on this one. We're going to save ourselves a few steps here. We had these two equations. Notice what we ended up with. We ended up with 9 divided by 4. So we took that number divided by that number. The a's canceled out. And we had b to the 5th divided by b cubed, which gave us b squared. So really, all we have to do, we're going to do something unusual. We're going to divide these two equations. So I'm going to take 13.2 and divide by 73.8. And then what happens here? What's a divided by a? A divided by a, those cancel out. B to the 7th divided by b squared is b to the 5th. So in essence, that's what ends up happening. You end up just simply dividing the two equations. And we usually do it to make sure that we take the big power divided by the little power so that we get a positive power. All right, so that saves us some work. I take 13.2 and I divide it by 73.8 and I get a nasty little number. And then to get the b all by itself, I have to do the fifth root. So I take the answer to the 1/5. And we get 0.71, so b is 0.71. I have y equals a times 0.71 to the x. I plug in one of the two pairs of numbers. It doesn't matter which one. I guess I will use the first one. 73.8 equals a times 0.71 squared. Divide, a is 73.8 divided by 0.71 squared is 146.40, we'll call it, rounding off to 2 decimal places. Final equation, y equals 146.40 times 0.71 squared. Questions on that one?
Squared should be the x.
To the x, yes, jeez. The x. Thank you. All right, number 4. Let's see if I can get a problem right here without making a mistake anywhere along the ways today. Find an approximate equation to y equals a times b to the x of the exponential curve for the graph. Round the value of b to 2 decimal places. Looking at that graph, can you tell me the a number? Yeah, the a number is 6. How do you know the a number is 6? Because that's where it crosses the y-axis. So we're going to have y equals 6 times b to the x. Now, how are we going to find b? Plug in another point. So what you have to do, you want to look at that graph and see if you can find another point. Hopefully one that looks like it falls right on a corner. Anybody see another point? Looks like 1, 3 is on the graph. So I'm going to plug that in. I'm going to have 3 equals 6 times b to the 1. Well, that's a very easy one to solve. B is a half. So final answer, y equals 6 times 1/2 to the x. I didn't quite follow the directions because it said round to 2 decimal places. That one came out real nice. There's no reason to round that one. All right, last one. How about this one? Can you tell me the y-intercept? Kind of, right? I mean, you could kind of guess. It's about 1.8, 1.9, somewhere around there. I'd rather not guess if I don't have to, though. What I'd rather do, if I can, is find 2 points and use those 2 points to solve exactly. So can you find 2 points? Looks like there's one. And 3, 12. All right, so we have 2, 6, 3, 12. So we're going to solve it like we did before. We're going to have y equals a times b to the x. We're going to plug in both of those points and then divide the 2 equations to find b. That's going to give me 6 equals a times b squared and 12 equals a times b cubed. When I divide, what's 12 divided by 6? 2 equals a divided by a. Those cancel out. B cubed divided by b squared. Just b. I subtract my powers. 3 minus 2 is 1. So that turns out very nice. B turns out to be a very nice number. B is the number 2. How do we find a now? Plug in one of the points. So we have y equals a times 2 to the x. I'll plug in the first one, I guess. 6 equals a times 2 squared. A is 6 over 4, which is 3 halves. So it looked like it was about 1.7 or 1.8. It really turned out to be 1.5. Interestingly enough. All right, so our equation is y equals 3 halves times 2 to the x. Questions on any of those?